Okay, so in this video, I want to go over something to keep in mind when you're using inheritance in C++, and specifically when you're deriving classes. So here I have a class, I'm calling it myBase, and it has two public methods, a constructor and a destructor, and all those do is just print out what they are. And again, to reiterate, we don't necessarily want to have output in our constructors and destructors, but the point of this particular program is to demonstrate what happens and when constructors and destructors get called. So I'm going to write a derived class. It's going to inherit from myBase. So I'm going to have a private member that's an integer pointer. And then my constructor, I'm going to allocate a new integer. And I'll print the value that A is pointing to and have it inline. And then for my destructor, it's going to be similar code, so I'll just copy that. So I don't need a parameter, of course, since it's a destructor. And we put the tilde on the front. I'm going to move these print statements to the beginning. So in my destructor, I need to delete A, and I need to set A equal to null pointer. That should conclude my derived class. So now let's take a look at what happens when we allocate some different variables. So first, let's do a stack variable, and then we'll make a pointer variable here. And we'll put some spaces in our code just so that we can see what's going on. So we create a stack variable, we create a heap variable, and then we delete the heap variable. We don't need to handle this because once this goes out of scope, the destructor will be called automatically. Let's compile this. So int argument given to, so this should be C2, not the number 2. I'm very glad C++ doesn't let us delete the number 2. So if we run this, interesting. We can't move that up to the top. What happened is when A was not initialized, so when we dereferenced it, it was pointing to some junk, and it didn't like that. So now we run this, and this looks good, right? So we get the myBase constructor, the myDerived constructor for 1, the myBase constructor, the myDerived constructor for 2, myDerived destructor for 2, myBase destructor. So notice the pattern that this goes in. We start off with the base constructor, the derived constructor, and then when we delete the object, whether it's automatically because it goes out of scope or if we call the delete function, we get the derived constructor followed by the base constructor. And the same thing happens with object 1. This is our stack variable. Notice the myBase constructor, then the myDerived constructor, the myDerived destructor, then the myBase destructor. Okay, so now you should recall from when we talked about polymorphism, there's no reason I can't do this. Now, instead of using the derived class pointer, I'm using a base class pointer. But again, that's fine. It limits what I can do using this variable because this variable only knows about the myBase members. But there's no problem with this pointer. I'm not going to get a warning or anything like that. So if I run this, myBase constructor, myDerived constructor, myBase constructor, myDerived constructor, that's good. But notice here when we call the delete for C2, we only call the myBase destructor. And the reason for this is because, remember in C++, the type of the pointer determines what gets called if it's a non-virtual method. So the moral of this entire video is make your base class destructors virtual. So now notice, now that it's virtual, it does get called as we would expect. So you may wonder, well, why don't we have to do this with the constructor as well? Shouldn't the constructor be virtual? Well, this is the call to the derived class constructor. So we don't need to worry about virtual constructors, because even though this is a pointer, this is getting called when the object is created, not when so it doesn't have anything to do with the pointer type itself. We're specifying create a myDerived object, so we call the myDerived constructor. When we delete an object, in that case, we're saying call the destructor for this. Well, this is a MyBase pointer, and so it's going to follow the rules of deciding which version of which object's method to actually call. So keep in mind, if you're going to derive a class, make it virtual.